Today is day 8 of Unit 5, the last day of the unit. We're going to be talking about cube root functions, but before, of course, we're going to go over our homework from yesterday. So you had questions 5, 6, and 7 at the end of square roots, graphing square roots, which is day 7. So for number 5, all it wanted to know was the domain of the function. Okay, so remember the domain of the function is going to be all of your x values. Okay, x values. So the first thing you're going to do is you're going to, now this goes to the right, so you're going to get the coordinate that is kind of your boundary. So it's not going to go any more to the left. So right off the bat, I know that -4 is going to be my boundary, okay? Because remember, we're talking about our x's, and it doesn't go any further. Also, if you put this into your calculator, if it's going to be anything less than a -4, so -5, -6, anything like that, it's going to say error. Remember, if it says error, you didn't do anything wrong. What that means is that the function does not exist at that domain. Okay, so again, since it is at -4, so again this is -4, 0 is my boundary. So right off the bat I'm going to cross off 1 and 2. And then secondly, I know that it can be at -4, because if you looked at that, -4 plus 4 is 0, the square root of 0 is 0. So that is going to be one of the answers. So, again, I told you yesterday this is called set builder notation. The way we read that is x such that x is greater than or equal to -4. So 5 is going to be choice 4. Okay, for number 6, you could have put that into your calculator. That probably would have been the best thing. So I have like the calculator screen right here. Remember, when you are subtracting on the outside, this moves down. Okay, please make sure you guys are being specific with your translations. I don't want to just know the direction. I want to know the exact number of units as well. So please don't just say it's translated down, it moves up. I wanted you to be more specific. Okay, and the last one we did, you had to actually graph and then answer a few questions. So remember, when you put this into your calculator, please make sure that everything is underneath the square root symbol. So if yours went down 5, that means that your -5 is on the outside. Okay, so also the other thing I want to show you, you don't need to choose. Now I want you to get the boundary number. I don't want you, so if I chose 4, see, my function doesn't go any more to the right than 5. Okay, so if I chose 4, you're going to get an error. But notice I go from 5, 6, and then I go all the way to 9. Okay, you don't have to choose numbers that have decimals. Just do the whole numbers. It's just easier to plot. Okay, make sure you have an arrow just on the one side, because it cannot go below this. We cannot have any negative y values. That is impossible. So the graph is translated 5 units to the right, and our domain is x is greater than or equal to 5. So the way I remember that, greater than or equal to, my graph is going to go like this. Less than or equal to, the graph will go, let me move that over a little bit. Or erase the whole thing. Cool. Okay, so if x is greater than or equal to some number, that's going to look like this. If x is less than or equal to some number, the graph will look like this. Okay, and that's for your domain. Okay, so as always, when we are graphing, please make sure you have your calculator out. I filled in some of these already just so I can talk about them. But again, today we are talking about graphing cubic functions. So the way that we write a cubic function, first of all, a cubic function is the opposite of of cubing something. Okay, so x cubed. The opposite of that would be a cube Okay, so our parent function is the cube root of 3. This little guy right here we call the index. Okay, if there is no index written, that is assumed to be a square root. Okay, so again, please make sure you have your calculator out for this. This is something new. So remember when we did the absolute value, we had to hit the math button, and then we went over to number, and then ABS was where we went. Well, now what you're going to do, go back to y equals, what you're going to do is you're going to hit the math button, and if you notice, if you go all the way down to 4, that is your cube root. Okay, so I'm going to click on that. So the cube root of x, go ahead and graph that. So remember, this is just a sketch. All right, so it kind of starts like this, and then it goes through 0, 0. So something kind of like that. Remember, it's a sketch, so it doesn't have to be, you don't have to plot any points or anything. So now, this one is a little bit, oops, sorry. That is a little bit trickier than the square root functions. So I just want to go over the domain and range because it is a lot different. Okay, so if you were to look at the values, what you would notice is, and I'm not going to go too far, but what you notice is that we don't have any errors like we did yesterday. Well, the thing about a cube root is the domain and range are actually all real numbers, okay? Because it is the opposite of cubing something. A cube root can be positive or negative. Okay, so that is the purpose, that is the reason, the main reason why we can have a positive or negative. So our range, again, it goes all the way from negative infinity to infinity. Notice that these are less than symbols. You cannot ever reach infinity or negative infinity. So that's why there can't be an equal sign under it. And then again, the description of a cube root function, a smooth curve extending infinitely in both directions. Okay, so yesterday it was just in one direction, which is because when you square something, it's going to be positive unless you negate it out front. So both directions. So for question number 1, we're actually just going to plot that parent function. I do see that it goes in both directions. So just going to look again to make my table. You will see it. Okay, I'm going to go all the way up to 10, just to negative 10, just because that's how far my graph goes. So I see I'm going to start at negative 8. Okay, so again, only pick the whole numbers. So I'll do negative, my pen would work, okay, negative 8, negative 2, what else? Negative 1, negative 1. 0, 0, 1, 1. So remember, you want to get the general curve, so get as many points as possible. I think we might be able to get 5, yeah. The other thing to notice is that this is going to be very symmetrical, okay? If you do not get something symmetrical for your function, again, take a look at the graph, okay? It's very symmetrical. All right, so if you plot those points, make sure you label. Remember, when I say label, just after you put that function on there, make sure that you write the function. Okay, so again, I just plotted those 3 points, and then the best that you can, make sure that that looks like a nice smooth curve. Okay, and we already did the domain and range. That would be just the all real numbers. All right, so let's plot question number 2. Now for this one, notice they gave us a specific domain, okay? So what that tells us is we are only going to plot numbers that come between -11, okay, -11 and 5, okay. Now, of course, I know how many there already are, so that's why I did my spacing. Okay, so let's put it in. Okay, so again, math, all the way down to the cube root. Go ahead and press that. So this is all underneath your radical. So you can do x plus 3 under parentheses, and then you are going to look at the table. Okay, so I know I'm starting at -11, so I'm just going to scroll all the way up to there. Okay, so at -11, it's -2. Again, we don't want any of these decimals. -4, -1, -3, 0. Uh, 5, 2. Oh, did I miss one? Okay, -2. Okay, again, remember we want to make it somewhat symmetrical. Okay, and then 5, what was that, 2? Yeah. Okay, 5, 2. So again, usually the magic number with a cube root is 5 points, if you can do it. All right, and if you notice, make sure you count. The graph is not a 10 by 10 like we normally have. So it does have room for -11. And kind of tying in our piecewise functions, notice that these are closed dots, okay? It tells us that we can be at 5 and at 11, so make sure that you have your open dots, your closed dots. Now, if I were to ask you what the range is, it's important that you understand this is the range. Okay, it wouldn't be all real numbers because the domain isn't all real numbers. So if I were to give you the range, the way you do it is 2 is less than or equal to y is less than or equal to 2. So you literally just use these numbers and take their coordinates with it. All right, question number 3. We want the cube root of x, and then we want to subtract. And then we want to subtract 4. So, hit your math button down to the cube root. Now I'm going to put the x in parentheses and then end my parentheses. If you have a different calculator, you're going to try to arrow out until you can see that the square root symbol, the radical, should end. Okay? Then do -4. Make sure you do minus, not negative. -4. Okay? You can take a look at the graph if you would like, just to kind of get an idea. And then we're going to look for those points. Okay, so we can kind of see which part of the graph we're going to want. Okay, so we're going to go, remember, always start at -10, just because that's what our graph has available for us. Okay. Again, it's not necessary for you to use your table, but I really, really, really think that it is the most beneficial thing for you to write that down. Then if your coordinates are wrong, I can tell if possibly you might have just typed it into your calculator wrong. That is a very common mistake. Okay, 0, -4. 1, -3, and 8, -2. Okay. So if you plotted those points, it would look like this. Okay, so describe the transformation from the parent function. So if I were to draw the parent function, that would be, let's see, here. Okay. So I'll just do a small little sketch. Okay. That would be, we'll say f of x is equal to the cube root of x. Okay. So you can clearly see that that moves down 4 units. Okay, so shifts down 4 units. You could also write translates. Okay, the last example problem we have today, and this should be a cubic function. Okay, so this should be, you're talking about the parent function, the cubic root. Okay. All right, so what we want to figure out, so we see that this is cubic just by the general shape, and then I want to see where it translates over. So again, what you're going to do is you're going to try to see where it goes through y equals 0. Or, yeah, y equals 0. So if you notice, right here, so at 3, 0, we have our curve, okay? And then this is still only up 1 and down 1, so -1 and so what's happening, this didn't stretch at all, okay? It moved to the right 3, okay? So if it moves to the right, that means it's going to be inside, underneath the parenthesis. Not the parenthesis, the cube root sign, okay? So again, start it like your parent function. So x, and then it goes to the right, so remember to the right is going to be minus, and then it's 3 units, okay? So just to do a little recap, so let's say I did +2, that would be up. If I did -2, that would be down. And if I extended this, if I do +2, that would be to the left. And then finally this one goes to the right. Okay, so for homework, I would like you to do questions number 5 and 6. Ooh, I showed you the answers. Okay, so numbers 5 and 6 are homework. For number 5, you're going to use number 2. And number 6 is tricky. So again, put this into your calculator. Okay, so you're going to type in 2 first and then hit this. Okay, so I'm just going to show you how to put that in your calculator. Okay, so do 2. Ooh, helpful if you could see it. So hit 2, and then you can hit the multiplication button if you want. Then do your math, go down and then do x plus 1. Okay. So that's what your graph will look like.